Let us spend some time to discuss on another data structure, queue. Let us start. Queue is a linear data structure where items in it are stored sequentially. The order in which items are stored and retrieved are done with principle of FIFO, first in first out. That is, the item which is added first will be the one to retrieved first. In the example, we can see how the elements 1 to 7 were added to the queue, and when removing it started with 1. To support the FIFO principle, queue is implemented with two operations, enqueue and dequeue, for adding and removing items. Along with operations, two exceptions, queue full and queue empty, are supported for exceptional cases. Let us see an implementation of queue data structures with arrays in Python. Let us take some time to go through the code. Here, you could see, we used Python list as the base data structure and implemented two functions, enqueue and dequeue, with that. We also ensured exception cases queue full and queue empty are handled. After the implementation, we added 10 and 20 in the same order. Later, during removal, 10 is removed first. And this implementation works as expected. It is really important to do the analysis of the operations on data structure. When you say algorithmic analysis, by default it means runtime analysis. For the Python list-based implementation discussed previously, we have order of 1 for both operations, and for the space it is order of n. The popular way of implementing queue is with arrays and two pointers called front and rear. A simple implementation for an enqueue operation will be to add the item in the location of array pointed by rear. Then increment the pointer. A dequeue operation will be to retrieve item pointed by front pointer. Then increment the pointer. Since both the pointers keep on incrementing the pointer, base array used has to grow dynamically to support this. By nature of the array data structure, it has to be fixed at the time of creation. We need to come up with some alternatives. A variation was done to the queue data structure, where the last element is connected to the first element to give a circular structure-like implementation. This is called circular queue. Because of structure, circular queue is also called as ring buffer. Let us see an implementation of circular queue data structures with arrays in Python. Let us take some time to go through the code. Here, we push two items into queue 10 and 20 in the same order. Later, when we removed an item, we got 10. It is really important to do the analysis of the operations on data structure. When you say algorithmic analysis, by default it means runtime analysis. For the array-based implementation discussed previously, we have order of 1 for both operations, and for the space it is order of n. Circular queue is a prominent data structure used extensively in internals of OS, like CPU scheduling, memory management. Many areas in Linux kernel uses it extensively. Let us spend some time in analyzing another variant of priority queue. The strict ordering enforced by regular queue is not always useful. We see lot of priority-based queues in real-life situation in hospitals, reservation centers for disabled, women, senior citizens. We need similar priority-based scheduling in computer as well. We need priority queue, a variant of the queue, to support this need. All the OS internal schedulers works with different priorities and use priority queues. While implementing a priority queue, we need to be sure on what is the variant we are about to implement. The enqueue operation should take another parameter priority, which will be used in TechQueue operation.